So last night I was trying to exhaust my highly uncoordinated cat with one of those little dollar store laser pointers.
Oh, yeah, those are great.
Right, and as that tiny red dot darted across the rug,
Yeah.
I found myself doing this weird thought experiment. Imagine taking that tightly focused beam of light and scaling the emitter up to the size of an entire galaxy.
And shifting the wavelength from visible red down into the microwave spectrum, I assume.
Exactly. It
Mm.
is such a wild mental model for what we're doing on today's deep dive. We're looking at our Wikipedia source material on megamasers.
These massive celestial
Yeah,
lasers.
to understand how they are unlocking some of the universe's greatest secrets. But real quick, before we jump into the physics, I want to thank our sponsor, Silk. If you are looking to integrate AI into your workflow, they are just fantastic. They handle everything from AI training and automation to custom software development.
Which is so needed right now.
Totally. Figuring out exactly where AI agents can make the biggest impact for your business or personal life is their specialty. You can check them out at embersilk.com.
Okay, so getting back to the actual physics of it all. The acronym MASER stands for Microwave Amplification by Stimulated Emission of Radiation.
Right. And since you tuning in likely already know the basic stimulated emission behind a standard maser, the real twist here is the environment.
Yeah, in a lab, you need these highly controlled resonant cavities, but in open space, you just have this sheer, unimpeded path length of a low-density vacuum.
It just does the heavy lifting for you.
Exactly, allowing the beam to amplify naturally over these vast cosmic distances.
And the scale of that amplification is just
Staggering.
yeah, when we talk about a megamaser, we are looking at luminosities 100 million times brighter than the typical maser we'd find in our own Milky Way. We are talking 10 to the power of 3 solar luminosity.
Which is the continuous energy output of 1,000 suns entirely concentrated into a single microwave beam.
Which completely explains why we can detect them from so far away. The first one we found was back in 1982, right?
Yep, a hydroxyl megamaser in ARP 220, which is the closest ultraluminous infrared galaxy to Earth.
And ARP 220 is the perfect poster child for where these hydroxyl megamasers thrive. They basically act as cosmic beacons for massive bursts of star formation.
Usually triggered by two galaxies merging.
Right, so all that chaotic interstellar dust and intense infrared starlight acts as the pump. It provides the energy to keep the maser firing.
Now contrast that with water megamasers, which hang out in an entirely different cosmic neighborhood. Instead of star-forming regions, water megamasers are typically located deep in the centers of galaxies, just swirling tightly around active galactic nuclei and supermassive black holes.
And this is where it gets incredibly optimistic for human progress and scientific solutions.
Yeah.
Because those water megamaser emissions are so narrow and well-defined, they give us a ridiculously precise tool.
Oh, completely. By tracking their velocity, we can calculate the absolute most accurate mass measurements of those supermassive black holes.
It is wild.
They also function as a direct cosmic tape measure. By observing the geometry and shifting of those water masers, we get highly constrained measurements of the Hubble constant.
Taking it from being just a neat astrophysical quirk to a foundational method for calculating the expansion rate of the universe.
Exactly. And meanwhile, those hydroxyl megamasers in the merging galaxies have their own utility. We can use them to map distant galactic scale magnetic fields.
Using the Zeeman effect right where the magnetic field actually splits the maser's spectral lines.
You got it. We can calculate the field's strength and direction across millions of light years. It really shifts your perspective. We look out at merging galaxies and intense environments around supermassive black holes, and instead of just chaos, we find perfectly tuned microwave lasers handing us the keys to measuring the cosmos.
It makes you wonder what else is out there.
It really does. If immense gravity wells and starbursts can naturally produce these perfectly tuned massive microwave lasers, you have to consider what other incredible naturally occurring quantum technologies the universe might be hiding, just waiting for humanity to discover.
I love that. What a hopeful way to look at the cosmos. Well, if you enjoyed this deep dive, please subscribe to the show. And hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.